What makes Earth's temperature earthy? One of the main things that makes Earth habitable for all living creatures is the greenhouse effect. So how does this process work? Let's consider this one-layer atmosphere model, beginning at the sun. Ultraviolet rays are emitted and make their way to Earth. Because the sun's rays are received at an area of pi r squared, while the Earth is absorbing it at a surface area of 4 pi r squared, this makes the radiation flux absorbed a fourth of the original flux, as the rate is lower. They eventually hit the roadblock of the atmosphere. Once UV rays reach this point, some are reflected due to the albedo, which is essentially the measure of reflectivity of the atmosphere, and some pass through the atmosphere. Earth then absorbs this energy and releases it back as infrared radiation. On this second pass, the atmosphere actually absorbs this infrared radiation. It is then re-emitted in random directions. Some of this is sent back out to space, while some is sent back to Earth. Based on this information, we can develop an equation for both temperature of the surface and the effective temperature of the atmosphere. First, we start with the equation rate of energy in is equal to rate of energy out. We apply this equation to both the surface and the atmosphere. The energy released by the surface is equal to the portion radiated back by the atmosphere and the energy the surface absorbs by the sun. Therefore, by fact, these two quantities are equal. One can use this to create the thermal balance between the solar radiation and the atmosphere radiation in relation to the Earth's emissions. With this, we can solve the surface temperature of the Earth. As the surface temperature is greater than the effective temperature, this shows the greenhouse effect causes the planet to be warmer, and that this model is not far off from the temperatures we have today.